Hello all. Today we are going to discuss the JEE Mains question paper chemistry part. This exam was held on 25th June 22. This is a memory based question paper, has been taken from the memory of the students. The questions may not be exactly same, but this will give you the overall idea of the paper. So here we got around 25 questions. So let us start the first question discussion. So which ion has our isoelectronic species with Al plus 3? So that means we should identify the species which have 10 electrons. Al plus 3 has 10 electrons. We know that magnesium plus 2 has 10 electrons. O2 plus O2 minus has 10 electrons. Na plus 10 electrons. Nitrogen is 7 plus 2, 9 electrons. Carbon 6 plus 4, 10 electrons. Cl minus is 18 electrons. F minus is 10 electrons. Magnesium plus is 11 electrons. So we can see that magnesium plus 2 and oxide have 10 electrons. Removing an electron from how many of the following species bond strength increases? Bond strength increase means bond order should be increased. So bond order to increase, we should remove an electron from anti-bonding molecular orbital. If the electron is removed from anti-bonding molecular orbital, the bond order will increase. So for that, we should write the electronic configuration using molecular orbital theory. Like for example, if you take B2, it is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, pi 2px1, pi 2py1. Okay. Here bond order is 1, number of bonding electrons minus anti-bonding electrons upon 2. So when we remove one electron, the electron is removed from bonding molecular orbital. So bond order is decreased by half here. So here bond order is decreased. NO has 15 electrons. If it has bond order 2.5, if we do it in similar way, when we remove electron, its bond order is increased to 3, 2.5 to 3. N2 has 14 electrons. Its bond order is increased from 3 to decreased from 3 to 2.5 when we remove one electron. O2 has 16 electrons. Its bond order is 2. We remove an electron from its anti-bonding molecular orbital, so bond order is increased to 2.5. C2 has 12 electrons. Its bond order is decreased to 1.5 when electron is removed. So the correct answer will be 1. Ionic mobility of which of the following second group metal ion is maximum? So in water, the ions will get hydrated. When ions are hydrated, the smaller ion will hydrate to maximum extent. When ions are hydrated, the smaller ion get hydrated more. Its ionic size in water will be maximum. So if ionic size in water is maximum, its mobility will be less. So out of these ions, beryllium 2 plus is the smallest ion which get hydrated to maximum extent. Therefore, its mobility in water is least. Whereas out of these ions, strontium plus 2 is larger ion. Its extent of hydration is less. So it will be hydrated less and its mobility is more. Next question is 5 gram of pent 1 react with how much of Br2 completely? So when 1 mole of alkene react with 1 mole of Br2, will get the addition product. So we can see that 1 mole of alkene react with 1 mole of Br2. So therefore number of moles of pentene given are 5 by 70. Therefore the moles of Br2 also 5 by 70. So weight of Br2 will be 5 by 70 into 160. That is coming around 11.4. So it's nearly it is 11 grams. So next question is on the density of sodium chloride. The density of sodium chloride solid is 43.1 gram per cc. It is asked to calculate the distance between Na plus ions and Cl minus ions. Here we have the structure of sodium chloride. In structure of sodium chloride, the chloride ions forms FCC and Na plus ions are present in the octahedral void. The octahedral void is present at the center of the edge. Now we can write that this edge length A is equal to radius of 2 times radius of chloride and radius of sodium ions. So for that we should calculate the edge length. So radius of Cl minus or distance between chloride and sodium ions becomes so edge length upon 2. So this is a simple question. We should know the structure of sodium chloride here. The density we can calculate that it is Zm by A cube Na. So if we substitute the values, we are getting the edge length as 2.08 into 10 power minus 8 centimeters. From this we can calculate radius of sodium and chloride ions, or distance between the chloride and sodium ions is A by 2, that is coming out to be 1.04 into 10 power minus 8 centimeters or 10 power minus 10 meters. So we are asked to calculate x, that is 1.04, that is nearly 1 will get. The next question is E naught of the cell is it is asked. So E naught for Fe plus 3 to Fe plus 2 and E naught I2 to I minus are given. So E naught of the cell is equal to E naught oxidation plus E naught reduction. Which is undergoing oxidation here? That is E naught I minus to I2 plus E naught Fe plus 3 to Fe plus 2. That is E naught Fe plus 3 to Fe plus 2 is given as 0.77. I2 to I minus is minus 0.54. So I minus to I2 will become minus 0.54. So on subtracting this, you will get 0.23. So it is asked x into 10 power minus 2 volts. So that will become 23. So next question is, it is asked to identify the strongest oxidizing agent among the following. Strongest oxidizing agent means we should note the electrode potential of these tripositive ions, that is Ti plus 3 to Ti plus 2, Cr plus 3 to Cr plus 2, vanadium plus 3 to vanadium plus 2, that is not given here, and Mn plus 3 to Mn plus 2, Fe plus 3 to Fe plus 2, cobalt plus 3 to cobalt plus 2. So we can see that due to increase in third ionization potential, the oxidation of Mn plus 2 to Mn plus 3, Fe plus 2 to Fe plus 3, cobalt plus 2 to cobalt plus 3 is difficult. So their oxidation from plus 2 to plus 3 is difficult. So reduction is easier. Therefore, these three species have the positive SRP values of M3 plus 2 to M2 plus, whereas these three species have negative SRP of M3 plus 2 to M2 plus. Therefore, these tripositive ions can act as the oxidizing agent, that is Mn plus 3, Fe plus 3, cobalt plus 3, whereas the titanium plus 3, Cr plus 3 are stable. They are not oxidizing agents. So we can see that Fe plus 3 can act as oxidizing agent. So next question is based on the chemical equilibrium. Here delta G naught is asked to calculate for the reaction N2O4 giving NO2. Here degree of dissociation is given as 50%. So N2O4 is giving 2NO2. If degree of dissociation is alpha, at equilibrium if you take initial moles 1 moles, equilibrium moles will be 1 minus alpha and 2 alpha. Kp of the reaction will be what? Mole fraction of NO2 into total pressure whole square upon mole fraction of N2O4 into total pressure. That is 2 alpha by 1 plus alpha into P divided by 1 minus alpha by 1 plus alpha square. So from this we can get 4 alpha square P by 1 minus alpha square. So from this we got Kp is 4 by 3. We know the relationship between delta G naught and Kp is minus 2.303 RT log Kp. On substituting this, the Kp which we got as 4 by 3 will get minus 684.7 joules. That is option 1. So it is asked what happens when precipitate of AgCl dissolves in ammonium hydroxide. So AgCl is a white precipitate. On adding excess ammonia, it dissolves to form a 2 coordinated complex AgNH3 twice Cl plus and minus. So we'll get option 3. So next question is based on the action of soaps. It is asked less amount of soap does not clean the action properly due to. It does not do the cleaning action properly due to. We know that soap clears the dirt by forming the micelle. The micelle formed in the water when the concentration exceeds the CMC, above CMC, above at certain concentration. Above certain concentration, soap forms micelle, that is called as critical micelle concentration. After that concentration only it can form micelle that binds to the dirt particles, and an emulsion is formed that will be removed by water. Along with the soap, that will go into the water. Therefore, the soap can act as the cleaning agent, cleansing agent above CMC only. So at low concentration, the value of the concentration of soap is less than the CMC. Therefore, it cannot act as cleansing agent. So the concentration should exceed CMC. Next question is how many of the following are electron deficient compounds? B2H6, PH3 some species are given. We know that boron compounds or 13th group compounds have the electrons less than 8. Therefore, they act as the Lewis acid, electron deficient compounds. Diboron, though it is dimeric, it has 3 center 2 electron bond. To this 3 center 2 electron bond, both boron don't get octet here. Therefore, this is also a electron deficient compound. PH3 phosphorus has lone pair, so it has the 8 electrons. So LiH is ionic compound. It is not an electron deficient compound. BCl3 has 6 electrons and boron. It is also an electron deficient compound. Ammonia has 8 electrons. Therefore, the B2H6 and BCl3 are electron deficient. Next, 0.02 moles of H2SO4 is present in 1 liter solution from which 50% solution is taken out. So if you take 50% solution, we'll get how many moles of H2SO4 taken out? 0.01 moles, because initially it is 0.02 moles. So to that again 0.01 mole of H2SO4 is added. So net moles of H2SO4 will be how much? 0.01 plus 0.01, that will be 0.02. So total millimoles will be 2 into 10 power minus 4 millimoles, that is 20 moles. 2 into 10 power minus 4 moles, that is 2 into 10 power minus 3 moles. We can write it as 220 millimoles. Next, so given 645 grams of a compound, determine number of atoms present. Here we can see that in the given 1 mole of compound we have 3 moles nitrogen. 1 mole given compound has 3 moles nitrogens. So for that we should calculate the number of moles of organic compound given is equal to weight by molar weight. We know that. So its molar weight is coming out to be 215 grams per mole. So 645 grams are given, that is 3 moles. So 1 mole has 3 moles nitrogen, 3 moles will have the 9 moles nitrogens. 9 mole nitrogen means 9 into Avogadro number, 9 into 6.02 into 10 power 23. Okay. So that becomes 5418 into 10 power 21. So I think they have asked x into 10 power 21. So what is x value here? 5418. Next, in extraction of gold, gold is dissolved in NaCl in presence of oxygen. What is the complex formed? We all know that it is a very well-known process, cyanide process, in which gold dissolves in cyanide in presence of O2 to form a linear complex. Coordination number is 2. That is AuCN2 minus is formed. Okay, very repeated question. Cerium plus 4 act as cerium plus 4. The stable oxidation state of the lanthanides is cerium plus 3 oxidation state. If any species is there in plus 4 oxidation state, that is readily reduced to plus 3 oxidation state. So if any species is there in plus 2 oxidation state, that will be oxidized to plus 3 readily. So plus 2 species act as reducing agent and plus 4 species act as oxidizing agent. Which of the following information is incorrect regarding Tyndall effect? The diameter of dispersed particle is much smaller than wavelength is used. This is wrong. So they should be comparable. They should not vary much in their size and the wavelength. So this is incorrect statement. So remaining statement we can see that lyophilic phobic colloids difference in refractive indices and of dispersion medium and dispersed phase are appreciable. Therefore, they show Tyndall effect quite well. So this is correct. Light thrown from a projector in cinema hall is example of Tyndall effect. This is a well-known phenomenon. Correct. So it is used to differentiate colloidal solution with true solution. This is also correct. True solution don't show the Tyndall effect. Which is the given related with the increase in eutrophication of pond water. So this is eutrophication is due to the increase in phosphate ion concentration in water, which is due to regular use of the phosphate fertilizers. So which increases the dense population of trees over the surface of water, and the dissolved oxygen in water will be decreased. Due to decrease in dissolved oxygen concentration in water, there will be loss of biodiversity in the water. So decrease in biodiversity is observed due to the eutrophication. So which of the following is an artificial sugar? So this is a simple question. Sucrose and lactose are natural sugars. Allicin is artificial sweetening agent. Codeine is a narcotic analgesic. So C is correct. Correct intermediate in the given reaction. Amide is reacted with Br to KOH. When amide is reacted with Br to KOH, this reaction is Hofmann-bromamide reaction. So in the first step, hydrogen of the amide is removed, that react with bromine to give this intermediate compound, which further lose H plus to Blaze, forming RC double bond N minus Br. This undergoes rearrangement to give isocyanate. This isocyanate on further hydrolysis forms amine. So isocyanate is formed as intermediate in Huffman bromide reaction. The correct IUPAC name of ethylene chloride. Ethylene chloride is CH3CHClCl. Ethylene chloride is CH2Cl and CH2Cl. So in ethylene chloride, it is a geminal dichloride. You can see that it is 1,1-dichloroethane. So 1,1-dichloroethane. Phenol with dilute nitric acid forms two different products A and B. Phenol on reaction with dilute HNO3 forms orthonitrophenol and paranitrophenol. So we know that they differ in the boiling points because this is associated with itself by intramolecular hydrogen bonding, whereas paranitrophenol form intermolecular hydrogen bonding. Due to intramolecular hydrogen bonding, its boiling point is less, and these two can be separated by steam distillation, which is a well-known question to all. Next question is, product of the following given reaction is. Here tertiary butyl chloride is given, that is reactive tertiary butoxide. Here SN2 and E2 possibilities you should see. This is a bulky base and strong base. This is a hindered alkyl chloride, which eliminates the possibility of SN2 reaction. So E2 reaction takes place. So beta elimination takes place to give this compound, which is an alkene. This is a 2-methyl propene. Next, this reaction is given, which is a Riemann-Tiemann reaction. So Riemann-Tiemann reaction, it is asked to identify the intermediate compound. This is directly from your NCERT textbook. We know that CHCl3 on reaction with KOH forms CCl2 carbene. That CCl2 carbene is attacked by phenoxide ion, which is formed by base action on phenol. Then CCl2 carbene is attacking this, forming double bond O, C minus Cl, Cl. Now this subtract this H plus, forming double bond O, CH, Cl, Cl minus, we can write its resonance, forming CO minus CHCl2. This compound on further hydrolysis changes to aldehyde. So the intermediate compound is formed, this CHCl2 phenoxide. Next, cumene is reacted with O2 in presence of light. Cumene hydroperoxide is formed. Cumene hydroperoxide on hydrolysis. Cumene hydroperoxide on hydrolysis. On acidification, it first undergoes protonation. This reaction is an example of migration to an electron deficient oxygen. The water becomes good living group now, thus O2 is removed, the phenyl group migrates to the oxygen. So phenyl group migrates to oxygen, forming the carbocation, which is resonance stabilized, on which water attacks to give OCOH. This on further hydrolysis produces phenol plus acetone. Very important reaction they have asked. Cumene hydroperoxide rearrangement reaction. The next question is, identify the staggered conformation with maximum dihedral angle. This is a simple question. We can see this is eclipsed. This is the staggered. This is staggered. This is eclipsed. So these two are eliminated as they are not staggered conformation. So the dihedral angle between the methyl groups in anti-conformation is 180 degrees here. Here it is 60 degrees. So the maximum dihedral angle with staggered conformation is this anti-conformation. So these are the questions of this paper. Hope this will help you to prepare for the next exams.